I'd like to thank Shark Defenders for inviting me to be here to speak with you today. I represent the Mystic Aquarium, which is a division of the Sea Research Foundation. The Sea Research Foundation includes the divisions of Mystic Aquarium, the Ocean Exploration Center, as well as Jason Learning. And together, our mission is to inspire people to care for and protect our ocean planet through education, research, and exploration. So today, you're going to learn a lot about shark biology from our fellow esteemed speakers today. You're going to learn about direct threats to shark populations, especially from unsustainable fishing, as well as from finning. What I would like to do with you today is to illuminate the role of sharks in our marine ecosystems, to illuminate the dependence of sharks on those ecosystems, and to bring home the message that shark conservation demands ecosystem conservation. So, when we think of sharks living in open ocean environments. We think of them as being disconnected from the ocean world or disconnected from other animals in the ocean world. We think of them as lone drifters in an empty sea, disconnected from marine habitats, disconnected from other species, and even disconnected from people. But it turns out that sharks are actually very dependent upon our aquatic ecosystems. Even open ocean dwelling sharks that live out in the open ocean depend on aquatic ecosystems in terms of their feeding patterns. Many of these sharks are piscivorous fish, which means that they're fish eaters. So they feed on these fish, which are in turn dependent upon the whole trophic cascade in marine ecosystems. These prey fish are dependent upon smaller fish, they're dependent upon invertebrates and crustaceans, and they're in turn dependent upon zooplankton and phytoplankton. So even in open oceans, a diversity of life is necessary to support shark populations. And then we have sharks that are much more directly dependent upon their habitats, like this zebra shark. Some sharks live in and on coral reefs. The reef is their habitat. They are dependent upon the reef for feeding, such as the case with these white-tip reef sharks. And these white-tip reef sharks also use the reefs for shelter, for protection from predation from other sharks that might want to prey on them. This is the horn shark. The horn shark lives in kelp forests along the warmer Pacific coast of the United States. It can also live in sandy flats, rocky bottoms, but it's always a benthic shark. It's always directly connected to its benthic habitat. It feeds on mollusks, it feeds on echinoderms, it feeds on crustaceans, polychaete worms, sea anemones, and even some fishes. And so this habitat is not only essential for the shark, but this habitat is also very essential for its prey. This is the epaulette shark, or the walking shark. The epaulette shark uses its paddle-like pectoral and pelvic fins to walk along the seafloor. It lives in Australia. It lives in very shallow water, in tide pools, in seagrass beds, also in coral flats, and it also feeds on benthic crustaceans, it feeds on worms, and it feeds on small bony fishes. So again, this is another example of a shark that is very directly dependent upon its seagrass ecosystem, and the prey that it feeds on are also very dependent upon this ecosystem. There are some sharks that live their adult lives in the open ocean, for example, lemon sharks. But what lemon sharks do is pregnant adult female lemon sharks will travel inshore and they will give live birth in warm, shallow lagoons. In there, juvenile lemon sharks will grow up. They will stay inshore and utilize protected nursery habitats like this mangrove nursery and rely on those habitats for food and for shelter. In those protected habitats, they are protected from predation from larger sharks, and they also find their food sources. They feed on benthic crustaceans and also small bony fishes. But it's not just sharks themselves that are under threat, but also the very habitats that they depend on. For example, we look at the industry of kelp harvesting. Kelp is an ingredient used in many food products and recipes, and it's also used in toothpaste, also used in soap and glass production. The removal of kelp removes habitat, it removes shelter, it removes a food resource. Svein Lorentzen and his colleagues in 2010 found that fish-eating birds, or cormorants, actually forage more in kelp-forested areas than they do in kelp areas that are protected. And as a result, the fish population's biodiversity declines in harvested kelp forests by up to 92% for some fish species. So there's a breakdown of the food chain with kelp harvesting. Bottom trawlers use beam trawls and otter trawls to catch seafood and bait. They catch ground fish and shrimp. The problem with bottom trawling is that it destroys seagrass beds and other bottom structure. So as these trawls roll over the bottom structure to catch these fish, the fish and invertebrates are disturbed from the bottom and are flipped into the net. In addition to the mechanical destruction of the bottom habitat, these bottom trawls resuspend sediment, so they reduce available light for bottom algae and plant growth, and they also resuspend pollutants and reintroduce those pollutants into the planktonic food web. Fishermen will sometimes venture out into seagrass flats to fish, and if they're irresponsible about that, if they have their outboard motors trimmed too low, if they don't use poles to navigate in very shallow water, the result is seagrass prop scars. And so the result in the community of animals living in those seagrass habitats is that we have lower abundances and growth rates of site-anchored invertebrates, like shrimp, crabs, and mollusks, and that has trophic impacts up the food web all the way to those sharks that depend on those seagrass habitats that we talked about. Boaters can do damage by irresponsibly anchoring on reefs, destroying reefs that are important for reef-based sharks. And then, of course, we have destruction of coastal habitats like mangroves, so that we can develop things like roadways, so that we can develop condos, so that we can develop resorts. This is a destruction of critical nursery habitat for sharks and numerous species of fishes and invertebrates, with the consequences of removing natural barriers, which leads to erosion, stormwater runoff, and loss of the filtration services that mangroves provide. And it also exposes these protected nursery areas and these protected waterways to further human intrusion and human exploitation. And then there are the wastes of our daily lives, the wastes from human waste, from food and liquid waste, chemical waste, washing our cars, inefficient sprinkling. All of these wastes end up in our water that ends up draining to treatment plants or into stormwater drains. The path that this water takes on the way out to the oceans is through streams, rivers, bays, and then finally this water, treated or not, ends up in our oceans. As a result of these many insults, we have a continuous decline of seagrass beds over decades, and unless we change the way that we live, these trends will continue. In the face of climate change, corals are bleaching. Corals depend on symbiotic algae living in their tissues to provide energy for coral growth and for life. When bleaching occurs, the symbiotic algae that live within those tissues are purged from coral tissues. And if those algae don't recolonize into living coral tissues, corals will die. When corals die, coral reefs deteriorate, and then therefore habitats for countless fishes, invertebrates, and sharks also deteriorate. So what can we do about it? The first step is that we need to know what's going on in our environments and with our shark populations. In the 1960s, residential development created canals and wetlands in southwest Florida that severely altered water flow to mangrove habitats, disturbing its ecology. Engineers are now restoring water flow back to its natural patterns, and my colleague, Patrick O'Donnell at the Rookery Bay National Estuarine Research Reserve, is monitoring juvenile sharks that use the 10,000 islands in southwest Florida as nursery habitat. He's detecting changes in shark populations and health over time as water flow to mangroves is repaired. We can engage in ecosystem restoration. This is Seagrass Recovery, a Florida-based organization that fills tubes made of biodegradable natural fabric sleeves with sediment and nutrients to support seagrass growth. These tubes are placed inside seagrass prop scars, and the benefits that the tubes provide is that they stabilize sediments, they fill in gorges created by the propeller scars or by the propellers. They allow rhizomes, or the horizontal roots of nearby seagrasses, to grow into new sediment, allowing new shoots to arise in scarred areas, and they replenish seagrass habitat for invertebrates, fishes, and benthic sharks. Mangrove restoration is also grounded in the principles of restoration ecology, that is, to assist in the boosting of the resilience and adaptive ecology of damaged ecosystems. The sites are carefully studied to ensure that they will support mangrove growth, so we pay attention to hydrological conditions and topographical elevations. And when ecosystem restoration is done in partnership with the community, that engenders community-based ownership and also community-based stewardship. These are my friends at the Coral Restoration Foundation. The Coral Restoration Foundation has adopted coral aquaculture practices that have been developed by aquarium hobbyists, and they have upscaled them for use in open ocean aquaculture. They fragment and then aquaculture these coral fragments in offshore sites. Once they get to a certain size, they are then transplanted out into damaged reefs. My colleagues are now studying gamete collection and mixing techniques for sexual reproduction of corals to boost the genetic diversity of the transplanted corals so that we can boost the genetic diversity of these restored coral reefs. Legislation can be important to provide for legal protections of animals, plants, and their habitats. We can implement sustainable fisheries management regulations, so that means imposing bag limits, imposing size limits, imposing gear regulations, and also seasonal regulations to make sure that the fish species that we're directing our fishing effort to can survive and sustain that fishing effort and can reproduce themselves on an ongoing basis. We can also implement responsible zoning laws for environmentally sustainable development. Some famous examples of global and national legislation include the U.S. Endangered Species Act, the Convention on International Trade in Endangered Species, and also the development of marine protected areas. These are areas protected from fishing and harvest, allowing the containing ecosystems to recover and flourish. These MPAs, as we call them, can also protect populations which migrate outside of them, but which require them for a part of their life cycle. So, for example, MPAs can help to protect important nursery areas. NOAA's National Marine Sanctuaries is a system of 16 marine protected areas throughout the United States, protecting coral reefs, mangrove forests, seagrass ecosystems, open ocean, kelp forests, and underwater canyons, and seamounts. Sustainable aquaculture is a strategy to provide an alternative to wild-caught seafood. We can reduce fishing pressure on wild populations and allow recovery. Of the seafood that Americans eat, about 86% is captured, and about 14% is, about 86% is imported, about 14% is captured or produced domestically. Of that entire lot of seafood that we eat, about 50% of it is aquacultured. World aquaculture production is valued at about $100 billion annually, and of that, only $1 billion annually is attributed to U.S. aquaculture production. So there's a major opportunity for development of domestic aquaculture to meet our demands for seafood. As consumers, we can ask our legislators, our grocery stores, and our fish markets to inform us about where our seafood comes from. Sustainable seafood comes from sustainable aquaculture. It comes from sustainable fisheries. When I say that, I mean fisheries that use fishing methods that are not destructive, where numbers and sizes of captured fish are regulated, and where species have reproductive rates that allow them to recover from fishing take. There are a number of sustainable seafood information resources out there for you to learn about sustainable seafood. I direct you to NOAA's fishwatch.gov to learn more. There are many things that all of us can do at home to improve our aquatic environments. Composting turns food and yard waste into nutrient-rich soil. We can then use that soil to nurture gardens and flower beds, and there are many benefits to composting. We can reduce the waste ending up in landfills. We can reduce or eliminate the need for chemical fertilizers and pesticides, therefore reducing stormwater pollution. We can remediate nutrient-poor soils, and we can promote the growth of gardens and flower beds, allowing them to act as stormwater filters. Recycling allows for the reuse of items that are no longer needed. Recycling can repurpose so many things. We can repurpose batteries, electronics, glass, metal, paper, plastics, styrofoam, and textiles. Many benefits to recycling as well. Reducing energy and mineral use by reducing production of raw materials, reducing waste that end up in our landfills, reducing greenhouse gas emissions, and also providing for economic development. Recycling creates jobs and provides materials for manufacturing. Some simple energy conservation tips we can implement at home: shutting off the lights when leaving the room. We can turn down our thermostats. We can unplug items when not in use and replace incandescent bulbs with fluorescent or LED bulbs. This reduces the demand for non-renewable and polluting energy extraction practices. Water conservation at home also by installing aerators on shower heads and faucets, turning the water off in between brushing the teeth and shaving, and putting a filled half-gallon jug in our toilet tank. This very directly preserves our aquatic ecosystems by reducing water drainage from aquifers and reservoirs. So the take-home message is that sharks do not exist alone in an open ocean. They are an important player in an ecological food web and depend on that web for their food, for their habitats in order to survive. In order to protect shark populations, we need to not only protect sharks, but we need to protect the marine ecosystems on which sharks and all of us depend. Thank you.